We have the limit of sine x over 3 roots of x as x approaches 0, claiming that this limit is equal to 0. Well, we do the direct substitution, plugging 0 directly in for x, as you can see here, and we end up getting 0 over 0. So that means we need to try to do something with this. So here's the trick that I pull. I've got the sine cubed of x, and it's all raised to the 1/3 power. Now, because this is cubed, a cube times 1/3 is just 1, and so we'd just be left with sine x in the numerator where we started. But the reason I want this to the 1/3, this way we can put a parentheses, as you can see here, around sine cube x over x, and this way we can take the whole thing and raise it to the 1/3 power. And now what I'm going to do here is I'm going to take the limit, as you can see, and write it inside of our parentheses. Now this follows one of our theorems that we might have talked about earlier, which I think I'm going to go to and take a closer examination of and then come back to the problem. Okay, I believe this is the limit theorem, one of the theorems for limits that I was searching for here. Let's read this. It says, if a function has a limit as x approaches a, then the limit of the nth root of f of x as x approaches a is equal to, now you see what I've done here, I've rewritten the entire limit up underneath the radical. Right, so we have the nth root of, and then we have the limit of f of x, x approaches a. Now, provided either n is an odd positive integer. Now, in our problem, n happens to be a 3. So that would fall under an odd positive integer. Or it says n is an even positive integer and the limit of f of x, x approaches a is equal to 0. But is greater than 0, I mean. So we are looking at this part of the theorem, n is an odd positive integer. So let's go back now to the problem. Okay. So we have put parentheses around the entire limit here, as you can see. And now we're going to break this up. This is sine cubed x over x. And we're going to break this up as a sine x over x times sine squared x. Now remember that the limit of sine x over x as x approaches 0, that limit is equal to 1. And we do the direct substitution here, plugging 0 directly in. The limit of sine x is 0, but if it's squared, 0 squared is still 0. So we have 1 times 0, it's all raised to the 1/3 power, and that's really 0 to the 1/3 power, which is equal to 0.